Okay, this is going to be the U-Substitution, if this thing will let me share the screen. There we go. All right, so before I even start doing the examples, and if you want to skip this, just skip this. But I thought it was worthwhile going over how to pick the U because people have trouble with it. The U is always something very simple and not complicated. If you look at the rules, I'm very bad at this. Like E, if you see E, the U is going to be the power of E. It's literally that simple, right? I mean, we know that the derivative of E to the U was E to the U du, but you're going to start here and go backwards, right? You're going to end up integrating E to the U du. Same thing here. You're going to start off with a fraction, but the derivative of the bottom is basically on the top. So if you see that, then you know that the U has to be what's on the bottom. Same thing. These rules right here, the chain rule. Remember, U substitution is the opposite of the chain rule. You are always looking for these things. You're looking for secant U tangent U du. As soon as you see that, you know the antiderivative is secant, and then you just put whatever the U was. So the U is always something very, very simple. It's not something complicated. So these chain rules are important to keep in mind. You have to know that's the whole point of this. You have to know these derivatives extremely well and know what you're looking for to go the other direction. Okay, so keep that in mind. The U, if it's E, the U is the power. If it's a fraction, the U is the bottom. If it's any of the trig dudes, then the U is the angle. And of course, obviously, if it's something being raised to a power, even if that power is a fraction, like a radical, like half power, third power, doesn't matter. The U is inside, right? It's what's being raised to the power. So hopefully that helps. And then I'm going to start doing the examples. Okay, the first one, I decided to do the ones that are later on in the worksheet rather than the early ones because, the class did the early ones already and we kind of went over those answers. So, like I was just saying, when you see E, whatever the power is the U. Now you have to. Some people are very imprecise when they write these. You have to be. If you're sloppy, lazy, half-assed with this is not going to cut it. You're going to be writing dx. You're going to be writing du. You have to write them very precisely, right? Remember, the dx means that this thing is a derivative. So when I take the derivative of u, we write du for derivative of u. Now the derivative of 10x is just 10. But it's 10 what? It's 10 dx, right? Remember, the dx means this is a derivative. That's my u. That's my derivative of u. So now I know that I have to replace everything, but I have to replace dx. So I have to solve for dx. So I'm going to divide both sides by 10. And I can very conveniently just erase that. Yay. Now I'm going to replace everything. I'm going to go back to my original integral. I'm going to keep that 2 there. You can put it in the front if you want, but I'm not. I'm going to replace the power with a u because that's what I did. Now, where the dx is, I'm going to put this. I'm going to put du over 10. Now, yes, I was putting the 2 here in the class, but it's the same thing. In fact, let me do that. So let me be consistent with what I did. So I'll move the 2 here. It's the same thing. I'm going to cross it out no matter what. So I'm going to put the 2 into the 10 and get 5. Now you got to be careful, right? This is 1/5. This is not 5 du. So you get 1/5 e to the u du. This is exactly what I want. I want a nice basic integral that I can find the antiderivative of. But when you integrate e to the du, you just get e to the u. And the 1/5, the constant in the front, just goes along for the ride. So now I'm going to just put my plus c. And then I'm going to go back and put my u where the power was. And again, you can very easily check these. I mean, I'm going to check them verbally. Don't forget the plus c. When you take the derivative of e to a power, it is e to that power times the derivative of the power. But if I times the derivative of 10x is 10, 1/5 of that is 2. What about 1? The derivative of 1 is 0. It's a constant. All right, so that's number 7. I'm going to do, like I said, I want to do the ones that are a little more complicated. Okay, so number 8. What I like about this one is that it involves factoring and canceling, which is important. So again, you have to be very precise. Whenever you see fraction, right? The derivative of ln u is du over u. I know a lot of teachers like to do this. It's 1 over u du. That's du over u. It's just, it makes no sense to split it up into 2 different things. It's kind of ridiculous, but whatever. So anyway, U is always the bottom. Now, you have to know ln that you have to know that ln derivative, or you don't know what to pick here. So, and if you pick wrong, it's just you're gonna get it wrong. So now I have to take the derivative of this again. Be very careful. The derivative of x7 is 7x6, right? Multiplied by the power, subtract 1. Now, because the weird thing about this is, you're doing antiderivatives, you're doing integration, but you're taking derivatives in the process of U-substitution. So you have to keep your mind straight about what you're doing. I mean, people get here and then they like add 1, divide. No, you're doing derivatives. So derivative of minus 3x is minus 3, right? Just take the coefficient. And then dx. This is really important. Got to make sure it's there, or you can't replace this. You have to get rid of all of it. Now, if you notice, this is really close to what I have up there. And if you're smart enough, you understand that all I had to do was double this to get what's there. So now I'm going to start. I got to get dx alone. So I'm going to divide this underneath. I'm going to write it nice and pretty, right? You do division here. Just put it underneath the du, the whole thing. So I get 7x6 minus 3. This is what I'm going to put where dx is. So now let me make that substitution. I'm never sure where to do this. I guess I'll do it here. I run out of room and the camera doesn't go all the way to the bottom. So u goes on the bottom, right? There's the u, bottom fraction. Now, the top has to stay there for a minute. So I put it there. But I replace the dx with that, right? This has to go there. So I'm going to get my du. That's exactly what I want. On the bottom, I have 7x6 minus 3. And again, this is where you have to do that little bit of factoring. You cannot just cross out like this. Right? It doesn't work that way. What you have to do is you have to recognize that the top has the greatest common factor of 2. They don't have an x in common. This does not have an x. You can only factor out the 2. So I'm going to factor out the 2 from the top. Cut them both in half. Divide them by 2. So that leaves you with 7x to the 6 minus half of 6 is 3. Yay, that's exactly what I have here. This is exactly what you want. The du stays there. And I put the 7x6 minus 3 back. I'm going to put parentheses around it to be really precise. Remember, you are allowed to do division across multiplication. This is multiplication. This is just, well, it's multiplication, right? It's u times that. So you're going to cross these out completely. I like to put the little ones for emphasis. Okay, so now that they're gone, you have a 2, a du, and a u. So put it all back together, right? You have the 2. You have the du on the top of that fraction. Look, there it is on the top of the fraction. You have the u on the bottom of the fraction. It's over. Antiderivative. You got to recognize that du over u is ln. So it's going to be 2 times ln u, because that's plus c, because that's the derivative of ln u. The derivative of ln u is du over u. Now just put that mess back, and I'm going to just write the answer up here for convenience, because it's hard to write down there. So it's going to be 2 ln of that original stuff. And you see it works. If you wanted to do the chain rule and check it, right, you would put this on the bottom of the fraction. You would put its derivative on the top, but then you have to double it because of this 2. So you would get 14x6 minus 6. So you could always kind of just check them in your mind. I would not recommend sitting there and doing the chain rule all over just to make sure you did it right. You should, if you set this up correctly, everything should cross out nice and neatly. You should get you get really basic integrals here. You get very easy things to find antiderivatives of. This is nothing too complicated. If you end up with something really crazy and complicated there, then you screwed up your choice of u. All right, I thought I would go back and do number 6. It's out of order since I did 7 and 8 already, but whatever. I could always edit this and put this in front of those, but I won't do that. I'll leave it in this order. Because I looked at this sheet and I realized, this one looks real nasty and intimidating. But it's actually not. I'm going to rewrite that integral a little bit. Now remember, if I had something like this, right? If I asked you to integrate that, you can't do it right now. Even if I asked you to take a derivative of that, you can't do it right now. The first step of that problem would be to replace the radical x with x to the 1/2, right? Square root is the 1/2 power, right? The 2 is the root. And also, you still could not integrate or take a derivative of that in its form. You need it to be, right, x to the p, x to a power. So you would have to take this one from the bottom and move it to the top, like so. So the first step would be to put the fractional exponent. The next step would be to switch the sign and move it up. So that's exactly what I'm going to do here. I'm going to have my 8x there. I'm going to take this and replace it with x squared minus 5 to the 1/2 power, because that's what it is. These are equal. Then I'm going to move it up. When I move it up, this power switches from positive to negative. That's what it means, right? That's a negative exponent. So there you go. Now, as I said when I showed you the rules in the very beginning, whenever you have something being raised to a power, the thing being raised to the power is your u. So your u is right there. Nothing complicated. I will see students pick the u to be radical x squared minus 5. You completely screwed yourself over. That's complex. Your u is never complex. Your u is always something very basic. X squares, x thirds, couple of numbers, some 3x, 4x. It's not complicated. The u cannot be something complicated, right? This is a ridiculous choice for you, and it's just not going to work. So you have to pick something very simple. So whenever it's something to a power, and yes, it gets confusing. You see the radicals, the cube root, square root, you get confused. It's easy to get confused. That's why you have to do these very carefully, very precisely. Once you rewrite it like that. Now, you should understand, that derivative is 2x. It's very close to what's there. That's the whole point of this, but it's off by something, and you got to figure it out. So derivative of x squared is 2x. Derivative of minus 5 is 0. It's a constant, and I put my dx. Now, again, the step was to solve, right? Divide both sides. So then dx is going to be du over 2x. Now, I'll make my substitution over here to make it a little prettier looking. So, and like I did in class, again, I should be consistent with what I'm actually doing when I do them in the class. I'm going to put the 8x over here next to the dx. I'm gonna do that step first, right? And then I'm going to put this where dx is, and I'm going to do it right now. So dx is going away. It's going away. And now du over 2x goes there. So that, well, actually, I guess I should put my u there too, right? I'll do it in the next step. So let's do it all in one shot here. That's going to be u. So I have u to the negative 1/2. Here I'm going to do my crossing out. 8x's divided by 2x's, right? 8 divided by 2 is 4. The x's cross out completely. And I'm left with 4 du. But I could write that all pretty. Let's make it look nice. Put the 4 in the front now. So I have 4 u to the minus 1/2 du. I mean, that is about as basic as it gets. That is basic power rule, right? But it's the reverse power rule, right? We're going to add 1 to the exponent. So once I integrate, I guess I'll do it up here. I'm going to add 1 to the power. So if you need to do it on the side. Remember that 1 is 2 over 2. So that's a half. Negative 1/2 plus 1 is a half. So my new power is 1/2. And then remember what I said to do. If it's a fraction, flip it over, throw it in the front, and multiply. Don't forget the plus c, right? So I added 1 to the exponent. I took the new exponent, right? If you divide by a fraction, you flip and multiply, right? Keep, change, flip. But I taught you in class to just take whatever's here, flip it over, put it in front, and do the multiplication. So I end up with 8u to the 1/2 plus c. But what was u? There it is. X squared minus 5. So let's put it back. X squared minus 5 to the 1/2 power. Now, look, you can leave it like that. I'm okay with that answer. But if you really wanted to be fancy and look all smart, you could put back the radical because it was there. In the beginning of the problem, it was there. So either of these answers is fine. I'm perfectly happy with that answer. If I see a correct U-substitution, you did it right. You got here. This is very important that you can get right there. That's the whole problem. Once you get there, again, basic integral. This is not a complicated thing to find an antiderivative of. We will. But right now, you're going to get simple things to integrate, not anything complicated. All right, I'm going to pick another one to do. Yeah, this is a good one. It's got a trig function. So again, when I showed you those rules in the beginning, this is the whole point. Tangent u, cotangent u, secant u, cosecant u, right? I have all those derivatives, and they're all chain rule derivatives with the u. So what I said to you was, whenever you see a trig, dude, the u is the angle. And there it is. That's my u. So the derivative of 6x is just 6 dx. Now, it's very important that you don't screw this up, all right? I mean, you can't, I see it. People take these derivatives wrong. You can't have this up in the middle of the problem. The whole thing is going to be ridiculously shot. So now I'm going to solve for dx. I'm going to divide both sides by 6. So I get du over 6. Now I just plug everything in, right? I'm going to have cos squared, you should recognize that, dude, of u times du over 6. There's nothing to cross out. There isn't. There's no number there. I could have put a 2 there. I could have put a 3 there, but I didn't. I didn't put any number there. So, if you want, remember, there is an invisible 1 here, right? You have to be very careful with this. You have to be precise. 1/6. This time I will move it out in the front. There's a 1/6 there. We never write that 1. You don't need to write that 1. But you have to recognize this is not 6. It's 1 over 6. So you get cos squared u du. So then you say, whose derivative of that? Let's see. Tan's derivative is secant squared. Cotan's derivative is negative cos squared, right? If I started with cotan u, and I took a derivative of that, I would get negative cos squared u du. Look at how close it is. It's off by this, and there's no minus sign there. If there was a minus sign there, the answer would be cotan. But you see I'm missing it. His derivative is negative cos squared. So when I do my antiderivative, I have to adjust for that. I have to put the negative there. The 1/6 has to stay there. That's my constant. So then this is going to be cotangent of u plus c. Right? Because if you take the derivative of cotan, you get negative cos squared. That negative and this negative eat each other up, and you get the plus here. Now just put the u back. I mean, this one, again, it looks nasty, but it's actually really, really simple. Jesus, would help if I had to say the correct thing down. Cotan 6x plus c. So, right, the derivative of cotan is negative cos 6x squared. Then the derivative of 6, that derivative, right, the derivative of 6x is 6. That 6 would eat up the 1 over 6. His negative would eat up that negative, and you would get back right there. So I know it seems a little weird, but again, you could check. I don't recommend sitting there and doing the chain rule a gazillion times, right? We're not in calculator anymore. We're past chain rule. We're doing the reverse chain rule. That's the whole point of this. But you have to kind of sort of in your head understand that the answer makes sense. If this negative is missing, it didn't work. If that negative is not there, the derivative of cotan without a negative here is negative cos squared. There isn't one there. So you screwed up. This is why you got to just, in your head, you check that to make sure that you have your signs right, because they're reversed. All right, you do another one. All right, so I decided to do 11, because it looks, there's a lot of crap going on there. That looks complicated. But when you do something like this, it should be a lot more clear who has to be the u. I mean, the derivative of tan is secant squared. But, right, this is not, right, people get confused about what to pick for u. This is not like secant squared 6x, because then my u would be right there. I told you that if you ever see the trig, guys, the u is going to be the angle. Now, what are you going to pick, x? No. It's going to be cosine u. This is the angle, right? Look, that's the cosine dude. That's going to be the u right there. It's cosine u. So the u is going to be tan. But that means that the derivative of tan is secant squared dx. Now, I mean, this one is spectacular, because once you plug in here, let me rewrite it. I'm going to put cos tan. I'm going to put the secant squared over at the end, so you see how clear this is. I'm going to replace this with u, so I get cosine u. And look at that. I mean, it's right in there. I don't have to do nothing. I don't have to divide this over. I can literally just put where secant squared x dx is, I can just put du. You don't have to divide it here. They're equal. They're exactly the same. So done. Look at that. There was my u. Tangent's derivative is secant squared. That's exactly what I had there, so I can just put du where secant squared dx is. And now, remember, going in reverse. Yes, the derivative of cosine is negative sine, but I'm not going in that direction. I'm doing an antiderivative. I'm integrating. So you ask yourself, whose derivative is cosine? It's sine. The derivative of sine is cosine. There's no switch there. The derivative of sine is not negative cosine. So you cannot put a negative there. It will not match when you check it. So then you just put back the u, which was my tan boy. So you put tan. So again, looked really, really complicated. It actually turns out to be very, very simple. The trick is figuring out who to pick for the u. If it's a trig dude, you pick the angle. There's no angle to pick here, right? This is nothing. That one is what you have to pick as the u, right? Because it doesn't have just an x there. It has something else. All right, so I decided to do another trig one, and then continuing my trend of doing them out of order, I decided to go do number 5 after number 11. So again, trig dude. Now look, they both have the same angle. They both have a 3x there. You would not, by the way, be able to do this if this was like 3x and this was 2x. That's not happening. So the u has to be the angle, right? Whenever you see a trig guy, the angle is right there. I mean, they don't put parentheses because they don't want people to think that it's a product. But now the derivative of 3x is just 3 dx. Okay, and then again, I have to solve. Here I am going to divide because I don't see any 3's here. So I'm just going to put du over 3. That's what dx is. Now replace everything. I'm going to put cosc u, cotangent u, and then where the dx is, I'm going to put du over 3. And remember, that's 1/3. So, you can throw it in the front. Just to get it out of the way. You don't need it there. So you have cosc u, cot u, du. Yay! Now again, this is where you need the chain rules. The derivative of cosc, right? Cosecant. The derivative of cosecant is negative cosc cot. So when I integrate this, I have to switch the sign. It's going to be negative 1/3 cosecant of u plus c. His derivative is cosc cot, but the sign switches. So I need that negative to offset the fact that there isn't one here, right? I mean, I don't really want to write it, but if I took his derivative, it would be negative cosc cot. This negative and this negative eat each other and make a plus. That's why there's a plus there. So you need the sign switch here. Now you just put back the 3x. It's over. It's cosecant 3x plus c. Right? I mean, the more of these you do, the more you get used to the idea of doing them, right? They can be tricky at first, what to pick, what not to pick, but the same patterns repeat again and again and again. So I'm going to do one last one. I'll do another trig one. I was debating which one to do, and then I realized doing 4, so I did 5, and I did 4. Going in reverse. So, I mean, I was looking at number 14, and then I realized that I just did one with cosine, so it makes sense to do one with sine. So, same thing. There's a lot going on here, but I have a trig guide. And when I see a trig guide, whatever the angle was is the u. Now, this is where you got to be careful. You got to take this derivative right, or it's going to screw up the whole problem. The derivative of x to the third is 3x squared dx. I see people do it wrong, and it messes up the problem. So divide over, right? Put this underneath the du. That means that dx is equal to du over 3x squared. Right? You have to do the solving step. You divide. Now, I'll be careful. I'm going to put sine. This time I'm going to put the u there. I'm going to take the x squared and I'm going to move it to the end next to the dx. Right? That's my move. I want to move this so it's closer to him, because this is what I was doing in class to make it easier for you to see. Now I'm going to replace that. And it's going to be like magic. You'll see it just happen. This is going to go right there. It's going to go right there. It's going to go right there. Oof, there it went. And again, you see that anything with x has to be gone. These cross out entirely. The red doesn't really work well with the black here. So those are gone. and you're left with, again, 1/3. This time I'll leave it in there just for variety. Put the third, you get sine u, gone, gone. The third is there, and then the du. That's it. I mean, look at how basic that is. So again, you got to be careful. I know that the derivative of cosine is negative sine. Now, if there was a negative here, no worries, perfect. But there isn't one. So again, I have to put it there when I integrate. So it's going to be negative 1/3 cosine u plus c. Remember, you're integrating. My du is gone. This is the derivative. That's why the du is there. This is the antiderivative. That's why the plus c is there. This is the original dude. This is the derivative of the original dude. So now just put what the u was right there. X cubed minus 2 plus c. Okay, now I'm looking at the sheet. I think, like I said, they get repetitive no matter how I try to avoid that, right? I mean, question 2 and question 7 and question 16 all involve e. So you just pick the power of e to be the u. Question 3, question 8, question 12 even, and question 17. They're all fractions, right? So they all involve, right? Look at number 17 there. It's broken. They all involve a fraction, which means that the bottom is the u. All the ones you see with the trig, dude, the u is the angle. Wow, one exception to that. Let me just really quick. I'm not going to do it. I'm going to start it.